Okay. Good morning. Good afternoon, everyone. Online students, am I audible to you? Hello. Dia, Darshan, Vansita. Am I audible to you all? Okay. Again, I'm telling you everyone that whenever I'm asking you to reply me something, you should unmute yourself and give me answer, right? Do not give your answer in the chat. Okay. Let us start our session with the quick recap of the thing we discussed in the last session. So in the last session, what was the point of discussion? So you can see here that what the thing we have discussed. We have first, in the last session, we have started about the discussion of chapter number 2. That is the linear application of op-amp, right? And when we are going to use linear application of op-amp, we are going to have the feedback amplifier. That means op-amp is going to be used with the feedback, either positive feedback or negative feedback. So what is the need of feedback? What is feedback? And what are the different types of feedback that we have seen in the last session, right? We have discussed about like voltage series feedback, voltage shunt feedback, current series feedback, current shunt feedback. That are the 4 main types of feedback we are using in our op-amp application. So that thing we have discussed, as well as by using the block diagram, we have understood that what do you mean by the voltage series feedback, right? So that thing also we have discussed, that when you say a voltage series feedback, that means we'll be taking the voltage signal from the output side and it will be connected in series with the input source. That is what we call it as a voltage series feedback. So that thing we have discussed in the last session. Now, in our today's session number 2 of the chapter 2, that is the linear application of op-amp, what will be your learning outcome? In our today's session, we'll first complete the discussion about that all remaining 3 types of feedbacks. That is voltage shunt feedback, current series feedback, and current shunt feedback. That's what we have started to discuss in the last session, but only we have completed first one, that is the voltage series. Now remaining 3 we'll be discussing today first, and then after we'll start describing the operation of voltage series feedback op-amp amplifier. That is going to be used in our actual op-amp circuit, right? So that we'll be discussing today. So let us start. First of all, what do you mean by voltage shunt feedback? See, it is very similar to the thing what we have discussed in the last session, that is about a voltage series feedback. In that, what we were doing, if I just remind you, you can understand that in the last session, when we have discussed about the voltage series feedback, there was a difference here on the input side, if you remember. Right? In that last session, you have seen that we have connected this feedback voltage. Feedback voltage means VF. This VF we have connected here in the series. If you remember, I have asked you to write down the Kirchhoff voltage law equation. Right? That will be helping you to write down that how you will be getting the equation of your input voltage to your amplifier circuit. That was given as a supply voltage plus feedback voltage VF. It could be positive if it is a positive feedback, or it could be negative if it is a negative feedback, right? So in the case we have discussed about that series connection, but today I'm showing you here the block diagram. You can see that here output side we will be taking the feedback of V0, that is the voltage output of the amplifier. That will be given to the feedback circuit here, having the gain beta. So according to the gain beta, you will be getting beta into V0 as a feedback voltage VF. And that feedback voltage is connected here on the input side in parallel to your supply voltage. You can see that supply positive will be connected here, supply negative is connected here. Similar to that, feedback voltage positive will be connected here and feedback voltage negative will be connected here. So you can see that supply voltage and your feedback voltage, they both will be coming parallel. That is what we call it is a shunt connection. And that's why it is called voltage shunt feedback. Am I making this thing clear, everyone? What is the voltage shunt feedback and how it is going to be different than voltage series feedback? Is that all right, everyone? Online students, can I get feedback from your side? Yes, there are many students online here. Can I get response from your side? Darshan, Ekanta, Nail, Vandan, Udit. Please do not use to write your answer in chat. Pujan, Ekanta, everyone. Why don't you unmute yourself and reply me? Either yes or no, whatever you have. Can you please do it? Pujan, Ekanta, Udit. Can you unmute yourself and reply me here?
Yes, sir.
Abhijit?
Yes, sir.
Yeah, so this is the good way of replying, right? Please do not use to type your answer in chat. Just unmute yourself and reply me here. So you will be also feeling like that you are in the live class. Okay, so that will be better. Anyway, so this is first what we have discussed about voltage shunt feedback, in which we'll be taking the voltage from the output side as a feedback, and that feedback voltage will be connected on the input side parallel to your supply voltage. If it is a voltage series feedback, then your feedback voltage will be connected in series. If it is shunt, then it will be connected in parallel. Now let's see another type of feedback connections, that is current series feedback amplifier. Current series feedback means what? Current series feedback means the feedback will be taken is of current signal first. Understand this thing. Whenever we are using the word current feedback, what that means? It means that from the output side of your amplifier, we will take current signal as a feedback. Am I making this thing clear? In our electrical circuit or electrical system, we'll be having either voltage or current. So if you are taking the voltage as a reference or as a feedback, it will be known as a voltage feedback, like in the previous two cases. But if you are taking current signal as a feedback, you can see here in the output circuit, there will be your output current flowing here, I0, right? That will be passing through your load RL, and that current will be flowing here in this direction also, because there is a closed path like this. So I0 will flow here also. So in your feedback circuit, what will be going? It is I0 only, right? So I0 will take the path through your feedback circuit. So your feedback circuit will get what signal? It will get the I0, not the V0. Understand this thing, everyone? We will be taking here in this kind of cases, output current as the feedback. What is the value of output current? What is the shape of your output current? That will be taken as a feedback in your feedback circuit. Now, what your feedback circuit will do? Feedback circuit will generate the voltage VF. Now, understand here one more thing. VF is a voltage. Though you have taken the feedback as a current, I0, but the value you are going to add over here or connect here on the input side, that will be in the form of voltage. But that voltage will be proportional to output current. Am I right? In previous cases, your VF was proportional to V0. Here your VF is proportional to I0. And that's why we are calling this as a current feedback. સમજાય છે? આગળના કેસમાં આપણે શું હતું કે આઉટપુટ વોલ્ટેજ ને ફીડબેકમાં લેતા હતા અને એના પ્રમાણમાં VF એડ કરતા હતા. અહીંયા પણ ઇનપુટ સાઇડ તો VF જ આવશે, જેને આપણે વોલ્ટેજ કહીશું. But that voltage will be proportional to output current, not output voltage. And that is why it is called as a current feedback. Is that right? And here again, you can see that current series feedback. Series feedback means the voltage VF will be connected here in series, like as a voltage series feedback. But the value of this VF will be proportional to your IG. So whatever feedback according to your current output you want to add here, that will be added in series with the supply voltage. Is that right, everyone? Now, similar to this, you will have one more. That is known as the current feedback, but it is a current shunt feedback. And again, you can see that from output side, will be again taking here current only, not the voltage. Whatever current I0 is flowing here, that current I0 will flow through the load RL, and then it will be taking the path from your feedback circuit. Like here, I0 will go here, it will go to your feedback circuit, then come back, or it will be come out and complete the closed path of I0 like this. But that I0 is flowing through your feedback circuit, and from that feedback circuit will generate the voltage VF, which will be proportional to your I0. But that voltage VF here, in case of shunt connection, it will be connected in parallel like this here. So wherever your supply voltage connection is there, parallel to that your feedback voltage will be also connected. So this is how you can have this 4 type of different feedback circuits or different feedback amplifiers: voltage series, voltage shunt, current series, current shunt, right? And out of this, any one of configuration of feedback amplifier can be used in the op-amp application. Is that all right, everyone? There is no need to draw it because I will be going to share this PPT to you all, right? You will be able to find this PPT in your canvas. And this kind of thing you will be getting from the books also, but no need to right now do it. You can just note down the points, what you find important. Yeah. Voltage series, okay. Let me show you voltage series feedback. It was there in last session, so I'll be, see, here it is. In the voltage series, from output side, you will be taking the voltage and connecting that in series over here like this. Okay. Then let us come to our today's session here. Here you can see that this will be voltage shunt. From output side, voltage will be taken and it will be connected in parallel to the input side. Then you come to the current series. So output side current will be taken like this and it will be connected in series with the input side here. So it is a current series. And then last, what we have just discussed is about current shunt feedback. Here you can see that the current will be taken, but the voltage VF will be connected in parallel. So this is how you can have 4 different types of feedback connections, or you may call that as a current feedback configurations. Did find everyone? Or still any doubt here? Okay. Now let us see voltage series feedback amplifier in our actual op-amp circuit. Okay, so I'm just going to show you that thing now. Look at here. This is what your actual op-amp, and that is connected as a voltage series feedback amplifier. Okay. Just a minute. Okay, so I hope that this is now more clear to online students. The diagram will be looking better now. See, this is a voltage series feedback amplifier. Now, in the previous block diagram, you already have seen that there was a 2 blocks. One block that was an amplifier block, and another block that is a feedback block. Do you remember that? Let me just show you that if it is not remembered by you. You look at here. There is one block for a basic amplifier with some gain A, right? And there is a feedback circuit with the gain beta, right? One more thing you should understand here, everyone, that in feedback circuit, your input is on this side. Understand this thing, everyone. For a feedback circuit, your input is on this side because your feedback circuit is taking output as an input. Here, for the basic amplifier, that is the main amplifier circuit having the gain A, is having your input signal coming from this side, input side. That is Vs will be your input and V0 will be your output. So the power flow from the basic amplifier circuit will be in this direction. If I just say like from the left side to right side of your PPT. Can you see this? On the other side, your feedback circuit, that feedback circuit have input on this side. That is, output will be given as an input here, right? On this side, can you see that? So right side will be the input here. And feedback circuit, right? So that you should understand and keep in your mind. Now let us come back here in our voltage series feedback amplifier. In this you can see our op-amp is your basic amplifier circuit. Here you can see that this op-amp is supplied with the plus VCC power supply and minus VE power supply here, and it is having the gain A. Which gain A I am talking here? It is an open loop gain of op-amp, which is having the value in terms of lakhs. We have already defined the characteristic of the op-amp, if you remember. બરાબર છે, op-amp ની characteristic આપણે already describe કરી દીધી છે. એમાંનો પહેલો જ characteristic point હતો, that is the open loop gain of the op-amp, and that gain is denoted by A. Sometimes it may be given suffix OL, A suffix OL. There OL stands for open loop. Open loop gain of op-amp. That is what the A we are giving here. Now you look at here. In this is V in, supply voltage. It is a, you may give VS also, right? That in the block diagram we have taken the word VS. Here you may call this as a VS also instead of V in. Now, how this is connected, you look at this. This dotted part is shown as a feedback circuit. You can see that. I already mentioned that thing here, feedback circuit. This dotted box is showing you the feedback circuit. Can you see this, everyone? Now, from the output side, you look at here. Here your output voltage V0 is there. Okay. Now, from the output side, this is what your RL load connection is there. You may say like that, this is the ground point. You see here, this is a ground. Here already it is given, but you can just add one more. Here, let us, you can consider this as a ground. Please focus here to understand the thing. In the circuit, you just see that this is the output load connection RL, and whatever voltage you are going to get across your RL, that is what your V0, output voltage, which is the voltage we are getting at the pin number 6 of our op-amp, right? This output voltage V0 is given as an input here to your feedback circuit. All right. In your feedback circuit, you can say like that. Let us say this is the terminal number 1, and this is, let us say, I'm saying the terminal number 2. So you are giving your feedback voltage V0 in your feedback circuit between the terminal number 1 and 2. Am I right? You're getting this or not? Online students, please add your points here if I'm able to be understood by you or not. I'm saying
Yes,
that
sir.
feedback voltage V0 from the output side is given to your feedback circuit between the terminal number 1 and 2, which I just mentioned here with the red color. Now, between terminal number 1 and 2, what is there inside? Inside, there is a series connection of RF and R1, right? That means it will be just doing a voltage division, like a voltage divider. If I show you here, suppose I have the 2 resistors connected like this. You look at on the other side, I'm going to draw one more diagram. Let us say I have 2 resistors connected like this. RF here and R1 is here. Okay. Here, let us say between these 2 terminals, I'm giving the name again here, terminal number 1, and this is the terminal number 2. Let us say between the terminal number 1 and 2, if I'm applying the voltage V0, okay, and I'm taking the output from here between these 2 terminals, and let us say I'm giving the name here VF. Can you tell me what will be the value of voltage VF here? Can you see this diagram? I'm just showing you the connection of RF and R1 in a different type of diagram. What will be the voltage VF? How the voltage divider rule is applied? That's I'm asking to you. આ બે રેઝિસ્ટન્સ છે RF અને R1 કે જેની એક્રોસમાં તમે વોલ્ટેજ આપો છો V0 અને R1 ની એક્રોસમાંથી તમે આઉટપુટ લ્યો છો જેનું નામ છે VF. તો VF નું ઇક્વેશન શું બનશે? What will be your VF equal to? VF is equal to R1 divided by R1 plus RF. This is a voltage divider rule, if you remember. Right? And this whole multiplied by total voltage, that is V0. Total voltage is V0. Can you get this, everyone? Hello? So the voltage VF, which is, you can say, the output of your feedback circuit. Here you can see in this diagram, VF is here. That is across your R1. Can you see that in this diagram? I'm showing you here in the cursor. You can see that. Can you see this, my cursor moving here across the R1? And the voltage VF, we are taking across R1. And you are giving your voltage V0 on this side between your RF and R1. That is what the same circuit I have drawn here also. Can you see the similar circuit here? I'm just showing you the connections. And according to that, you will be able to find what is the value of VF. Can you understand that or not? Guys? Which is the output of your feedback circuit is connected on the input side. Look at that. On input side, input side, there is a supply voltage V in, and this voltage VF comes on this side. So in this input side, there is a closed circuit. You can see here. This is what VID. VID is what? It is the actual input to your op-amp. Right? So if you apply the Kirchhoff voltage law, you can just give that your input voltage V in here. If I write down here like this, what will be my, let's start from here writing Kirchhoff law, right? I'm just moving in this closed path like this. Okay. So how will I be completing the Kirchhoff law equation? I'm going from negative to positive. So I can say plus V in, right? Here it will be plus V in. Then let us say here VID. Let us say here it is plus and minus. So you'll be saying that it is minus VID, isn't it? And then I'm coming to here VF. It is also plus to minus. So can I say minus VF is equal to 0? Yes or not? And from this, if I take VID on other side, you will be able to see that VID equal to what? V in minus VF. That means this is a negative voltage series feedback amplifier, isn't it? Which kind of feedback it is? VID means it is a differential voltage between the two pin of op-amp. That is there in the diagram. You can see that, right? VE. Right? So this is what you can say a series feedback. Which type of series feedback? Voltage series feedback. Why it is voltage series feedback? Because you are taking the output voltage as a feedback and connecting the voltage in series on the input side. Koni series ma, supply ni series ma. Are you getting this? But here you can see that your feedback voltage is subtracted from the VN. Matlab Vin is positive minus VF. So you can say it is a negative series feedback. It could be positive also, it could be negative also. So which type of connections you are making? According to that, it will be either positive or negative. So right now this circuit is, you can say, series negative voltage feedback, or you may say voltage negative series feedback. Am I making this thing clear, everyone? Or any doubt here? Yeah, you can draw करूँ तो कर ही लियो, वांधा नहीं, जरूर पड़से. You can just draw this simple diagram. Yeah. What should I repeat? Just a minute. Okay. So what I'm saying is, yeah, what you want to ask to me? What should I repeat? What should I repeat? See, this is a voltage. Wow. Okay, so now if you understood, let me tell you one more thing here about this. That if you look at this connection diagram, here supply voltage and the feedback voltage, this both we are connecting to the non-inverting terminal of the op-amp. You can see that supply voltage positive is going to the non-inverting terminal of the op-amp. That is the positive input of the op-amp. When I say non-inverting input of the op-amp means what? It is here, right? That is the positive input. This positive input of the op-amp is known as the non-inverting input of the op-amp, right? And that's why we can say that this is a non-inverting amplifier also. You can be saying this circuit as a non-inverting amplifier also. Are you getting this, every one of you? Why this amplifier circuit is known as the non-inverting amplifier? Because here your input is given to the non-inverting input. You can see this input connections going to where? It is going to the non-inverting, or you can say positive input of the op-amp. that is at the V1 terminal. So that's why it is known as the non-inverting amplifier. You can see here already written that thing. So this kind of closed loop non-inverting amplifier, or it is a simply non-inverting amplifier also. So whenever you have been told like that non-inverting amplifier, so you can simply understand it is a voltage series feedback amplifier, right? In the future, we'll be not calling this as a voltage series feedback amplifier, but we'll be knowing this as a non-inverting amplifier. It is a voltage series feedback amplifier only. But આપણે generally કયા નામથી જાણીએ છીએ? Non-inverting amplifier. Okay. Now, one more thing that I would like to tell here is, in the previous chapter, we have described the various characteristics of the op-amp. That is the open loop gain, offset voltage, bias current, then so many different characteristics we already described, right? But that all characteristics will be going right if you are using only op-amp. Only op-amp in the sense, you are giving some input to your op-amp and taking output from that op-amp. Then only that is going to be true. But right now, if you look at this circuit, here we are not using only op-amp. We are connecting this op-amp in a closed loop with a feedback circuit. So now, when you are using this as a closed loop feedback circuit with the op-amp, its behavior will be changing. For example, let us say you have a something, let's say very spicy thing you are having in a dish, but you are adding sugar into that. Will that remain still that much spicy, or it will be changing? At something, some food you have which is very much spicy right now, so you come to know that this is a very much spicy, and now you have taken a sugar and you have added the sugar into that. After mixing it properly, you have taken again. Will you find similar taste? No, obviously not,
No.
right? That spiciness will reduce, isn't it? So that thing will happen here also. If you use your op-amp single without addition to any other circuits, then it will giving you same gain, that is the open loop gain, and the similar behavior with all the parameters. But now in this case, we are adding it with the feedback circuit. We are making it is a voltage series feedback amplifier now. We are adding that feedback circuit. Means it is now a closed loop circuit. With op-amp, that feedback circuit is also there. So now your op-amp or overall behavior of this amplifier circuit will not be similar to that what your single ideal op-amp is. Like એકલું op-amp વાપરશો અને આ feedback circuit સાથે વાપરશો તો બંનેમાં difference હશે. સમજાય છે? So that thing we have to now derive. Now what should we have derived? કે ભાઈ હું એકલું op-amp વાપરતો હતો તો એનો feedback input impedance આટલો હતો, output impedance આટલો હતો, કે પછી એનો open loop gain આટલો હતો, કે એની bandwidth આટલી હતી. But now you are using that op-amp with the feedback. So now you have to again cross-check, or you have to recalculate that what will be now its input impedance, what will be now its output impedance, and what will be its overall gain, what will be the bandwidth. So that everything is now you have to recalculate. Am I making this thing clear, everyone? Why I'm asking you to recalculate the thing? Because now in this kind of circuits, we are not using op-amp as a individual component. It is connected in a closed loop manner with the feedback circuit. So there will be change in your input impedance of the overall amplifier. There will be change in the output impedance of the overall amplifier, as well as your gain and bandwidth of the overall amplifier. So that we have to calculate. Are you getting this, what I'm saying, everyone? Online students?
Yes, sir.
So now how can
Yes,
we do
sir.
that? Let us first we find out what will be the overall gain. Your open loop gain of op-amp is there, capital A, right? Capital A is the open loop gain of your op-amp is there already given to you. But now when you connect this kind of feedback circuit, what will be the overall gain of this now with the series connection of this voltage feedback? So let's derive that. So here you can see that. Before we derive that, let us first you keep this thing in your mind. Some various gains in the feedback amplifier. When you have simply op-amp without any feedback, you will have only one gain. That is what we call it is the open loop voltage gain. What is the formula of open loop voltage gain? It is the output voltage divided by VID. Now, what is VID here? VID is the differential voltage between the two input pin of the op-amp. Don't be get confused here. There are three gains we are going to describe here. The very first gain is the open loop gain. Open loop gain એટલે કયો gain? તો કે op-amp નું output અને op-amp નું input એનો રેશિયો લ્યો અને જે મળે that is your open loop gain. Op-amp નું input એટલે કયું? VID. Vin is not the op-amp input, right? You look at in the previous circuit here. In this circuit, અહીંયા જે Vin છે that is not your op-amp input. Op-amp input means VID. That is the between your input pins of the op-amp, or you can say input terminal of the op-amp. So output of the op-amp is V0, and input of the op-amp is VID. So if you take this ratio V0 by VID, that will give you capital A. That is what your open loop gain. Is that clear, everyone? Do you clear concept of open loop gain in your mind? Yes or not?
Yes, sir.
Okay, thank you. Now, second one is the closed loop gain. Now, what do you mean by closed loop gain? Closed loop gain means it is the overall gain of your amplifier. In the previous circuit, if I just go back that previous circuit here, you can see that in this amplifier circuit, output is your V0 and input is your supply voltage Vin. So if you take the ratio of your output voltage divided by input voltage, then it is known as the overall gain of your amplifier, or you can say it is a closed loop gain of your whole circuit. So that's what you can describe with this formula. And we will be going to denote it by AF. AF means it is a closed loop gain. We'll be putting suffix F. Capital A will be there for the gain, but in suffix we'll be putting the capital F. So that AF means it is a closed loop gain. In presence of your closed loop circuit, what will be the overall gain of your amplifier? That is given by a AF, and it will be taken as a output voltage divided by input voltage. And the third gain we want to describe here, that is the gain of your feedback circuit. In the feedback circuit, if I again take you back to the circuit here, look at that. In this feedback circuit, what you can see here, the input voltage here, what it will be? Your input voltage is V0, right? And what is your output voltage is your VF. So if you want to give a gain of this feedback circuit, let us say capital B, then you can say that the capital B is equal to output divided by input. Now, what is the output of that feedback circuit?
VF.
It is VF, not V0, right? Feedback circuit output is VF and input is V0. So if you take the ratio of VF divided by V0, that will give you capital B. So that equation is taken here. VF divided by V0 will give you the gain of feedback circuit. So in this voltage series feedback amplifier, we have three gains. One is that for open loop gain of your op-amp. Second one is the gain of your feedback circuit. And third one is the overall gain, or you can say closed loop gain of your voltage series feedback amplifier. Am I making this thing clear, everyone? Yes. Dia, Vansita, Amit, Pujan, am I making this thing clear?
Yes, sir.
Dia, please don't use to type your answer in chat. Unmute yourself and give the answer. Can you give the answer, Dia? Hello, Dia. Can you unmute yourself and give me the answer? Hello, Dia. I'm waiting for your response here. I allowed everyone. You can unmute yourself. You can just click on unmute. You will be allowed already. Right? I'm always keeping you all students to be unmute yourself anytime. Yeah, it is there. See, other students are already giving the answers. right? And I'm again just doing that thing. Anyway, let me move forward now. I just described these three different types of gain because now I'm going to derive all this. That is, first is closed loop gain, right? That is what the most important thing you have to derive, because open loop gain is already given to you, right? Out of these three gain, your open loop gain, that is capital A, that you will be given, because when you purchase any op-amp, you will be able to see that what is the open loop gain of that op-amp into the data sheet, right? Similarly, the feedback gain beta or capital B, that also you will be able to find from the components you are going to select for your feedback circuit, right? The only thing that you have to find out and calculate the formula is for closed loop gain AF. So let's derive that thing here. So here in this particular op-amp feedback circuit or voltage series feedback circuit, I have taken that same circuit again here, right? Here it is a negative voltage feedback circuit that I already explained to you. If you write down the Kirchhoff voltage law equation here on the input side, considering that your VID having plus here and minus here, and if you start from writing here from V in, you can write down that plus V in, then minus VID minus VF is equal to 0, right? And from that, if you take the VID on other side, you will be getting this formula, that your differential input voltage of your op-amp, that will be given by V in minus VF, right? This thing we already have discussed in the previous slides, right? So is that part clear? Right now, what we are doing, we are deriving the closed loop voltage gain, okay? So with this equation, you can just able to derive that thing. So how can we find it out? So closed loop gain is given by what? Closed loop gain is going to be given by the equation. We already have taken this equation, that output voltage divided by input voltage. Now, what is your output voltage? If you just go back this circuit, what will be the V0 here? In this diagram, if I want to write down V0, what it will be? Can I write down it like
Output
this?
voltage.
Yeah, can I write like this? A into VID or not? Can I write down the output of the op-amp as a input of the op-amp multiplied by the gain? Can I do like this or not?
Yes, sir.
Now, what is your VID? Your VID is the difference of V1 or V2 or not? So can I say like that it is equal to capital A, that is the open loop gain of op-amp, in bracket, it will be V1 minus V2. Isn't it? Can you see this, everyone? Can I get V0 like this? That V0 is equal to capital A in bracket V1 minus V2. So that same formula is taken here also. You can see that. V0 is equal to A in bracket V1 minus V2. Okay. Now, what is your V1? Again, just go back to the circuit. Now, V1 means what? If you want to measure the voltage here at the V1, what it will be? You are connecting your input voltage here. See this. Input voltage positive terminal going to this positive input of the op-amp, right? So if you put a multimeter here, if you put one pin of multimeter here at the V1 and other at the ground, what the value of V1 you will be finding? It will be V in only. So simply I can say my V1 is equal to V in. Yes or not? Can I say like this? V1 is equal to my V in, because that is connected at that terminal, right? Yes or not? So that's it taken here, that your V1 is equal to V in. Can you see that? Now what is V2? You look at here. V2 means other terminal of your op-amp. There we are connecting the positive terminal of your VF. It is going here, right? So simply I can say that V2 is equal to VF. Can I say like this or not? Now what is VF? If I have written V2 is equal to VF, can you tell me what is the VF? VF is equal to V0 or anything else? શું આવશે? V2, sorry, VF શું હશે? Anyone, online students can also give the answer here. What will be your V2 that is equal to VF? I just talked about this in previous slides. Why you forgot that? હમણાં જ વાત કરી આપણે, કેમ ભૂલી ગયા? VF is equal to, but what I'm asking the value exact. V0 upon VID. No, how VID can be there equal to VF? VF is equal to R1 divided by R1 plus RF multiplied by V0. Why you forget this thing? It is the output of your feedback circuit, isn't it? Right? This whole going to be multiplied by V0. Can you understand this, everyone? So this is what your V2 and V1. How this equation comes, can you all understand this or not? Now that equation we have taken here, you can see that Vin is equal to V1 and V2 is equal to Vf, that we have taken here like this. So if you put this value of V1 and V2 in this equation, so what you will be getting? V0 equal to, can I take A as it is here? In bracket, in place of V1, I can take Vin, so that will be here, right? And in place of V2, I can put the value of Vf, that is, you can say R1 divided by R1 plus RF into V0, so that I have taken here. Can you understand this, everyone? ખ્યાલ આવે છે ભાઈઓ? આ ઇક્વેશન લાસ્ટ જે છે કેવી રીતે આવે છે? V0 equal to, is that clear, everyone? Yes or not? Online students, I'm not getting any response from your side.
Yes, sir.
So now what you have to do is, you just need to simplify this equation. So when you do the simplification of this equation, what answer you will be getting? You will be getting this equation or this formula now. You look at here. You will be getting this equation. AF is equal to V0 by Vin, and that will be equal to this equation. How you will get this? Let me tell you. Go back this slide again. You can just like this, you can write down like this, V0 equal to, you can write down A into Vin, right? I just opening the bracket. Then can I write like minus A into R1 into V0 divided by R1 plus RF. Can you do like this? Right? Now what you do? You take this term of V0 on the same side. V0 is already there. So I can rewrite this equation like this. From this equation, I can write it like this. That on other side, I can take V0 as it is. Now minus AR1 V0 upon R1 plus RF. When we go on this side, it will become plus. So I can say V0 plus AR1 into V0 divided by R1 plus RF. Can I do like this? And this is equal to what? Only the term remains on this side, it is A into Vin. Am I right? Clear? Now you can take the V0 common on this side. So if you take the V0 common, what you will be getting? I can take like this, V0 common. In bracket, it will be what? 1 plus AR1 divided by R1 plus RF. Right? This will be remaining on this side. And on other side, it will be A Vin. That will remain as it is. Right? Capital A into Vin. It will be as it is. There is no change in that. Can you understand? Now what you need to do is, you just take V0 divided by Vin on other side. And remaining all thing other side. You can just do that simplification. Are you getting what I'm saying? You keep this V0 as it is here on this side, and you take V in from this side to this side. So you will be getting this ratio equation. V0 by V in is equal to, you will get this kind of simplified equation. I'm keeping this simplification for you now. Now remaining simplification, you can do it. And you will be able to derive this. That your V0 divided by V in, you will be getting equal to A in bracket R1 plus RF divided by R1 plus RF plus AR1. This is what you can say exact closed loop gain equation. This is the exact closed loop gain equation. According to the value of R1, RF, and A, you will be able to get this. Can you get it? Now, if you want to make it simplified, or you might say put some approximation, because here you can see this equation looks little bigger. So if you want to make it simplified and with some approximation, what we can do is we can apply the approximation here in denominator. Denominator ની અંદર આપણે approximation આપી શકશું. કયું શું approximation થશે? What approximation you can apply? Can you see this? What is the value of R1? What is the value of RF? And what is the value of AR1? R1 and RF is what? It is the two resistance there in your closed loop feedback circuit, right? Now the value of that resistance could be, let's say, 5 kilo ohm or 10 kilo ohm, 20 kilo ohm, something like that, isn't it? मतलब के 10,000, 20,000, something एवी value हसे, कोनी R1 and RF. But compared to that, what will be the value of AR1? मानी लो कि R1 ની value 10k છે, for example. R1 ની value 10,000 છે, એટલે કે 10k. Okay, how much value of R1 is there? It is 10k. And let us say RF ની value છે, માની લો કે 20k છે, for example. RF is 20k. मतलब કે R1 ની value 10,000 છે, RF ની value 20,000 છે. But now what is the value of capital A? Capital A ની value કેવી હશે? What could be the value of capital A? Capital A શું છે અહીંયા? What is the capital A here in equation?
Sir, gain.
It is an open loop gain, right? Now, what is the range of open loop gain? It is going to be in terms of lakhs, right? 2 lakh, 3 lakh, 4 lakh, something like that. And that gain is in product with your R1. R1 ની value 10,000 છે. Example આપું છું એના માટે. અને ધારો કે તમારો gain 2 લાખ છે. તો 2 લાખના ગુણાકારમાં 10,000. So what will be that number? 2 lakh multiplied by 10,000. It will be very large, isn't it? 2 lakh means 2 બેની પાછળ 5 મીંડા તો છે જ, અને 10,000 ના બીજા 4 મીંડા. That means after 2 there will be 9 0 will be there. It will be a very large number, isn't it? So અહીંયા R1 plus RF કરો બેનો addition. So 10k plus 20k it is equal to 30k. Means 30,000. તો 30,000 ની સરખામણીમાં એ જે નંબર આવશે કેવો આવશે? It will be very large. A multiplied by R1 will be too large compared to R1 plus RF. So I can say like that, AR1 product will be very large compared to R1 plus RF. So you can put this approximation here. That's what I'm explaining to you. Like in denominator, instead of considering R1 plus RF plus AR1, you can simply consider it to be AR1. સમજાય છે? You can approximated voltage series feedback amplifier closed loop gain, or you can say non-inverting amplifier closed loop gain, then it will be given by this. So this is what the last formula of closed loop gain we can derive. It is called approximation, right? This is not exact. It is approximated, right? Can you understand this, everyone? Hello, everyone. Have you understood how can we derive this closed loop gain of non-inverting amplifier?
Yes, sir.
Any doubt here?
No doubt, sir.
Okay. So remaining parameters like what will be the input impedance, what will be the output impedance, what will be the bandwidth for this non-inverting amplifier configuration, that we'll be discussing in our next session. If you have any doubt till here, you can ask me, or otherwise you can give your number and so that we can close the session. Meanwhile, online students entering the number, let me take the attendance from here, offline students. Yeah, can you give your numbers? GTU D2D 4. GTU D2D 4 and 1. Okay. Can you just give your number? Sorry, names. Name. Nitin Kumar. And here is Rajesh. Okay. Now your MUD2D 3, 5, and 6. Okay. Okay, online students, I hope that every one of you have given the number for attendance. Thank you, everyone. I'm just going to end the session now.